Good morning, Porto. Woo! Are you all excited to be here? Excellent. So to show our appreciation for this really amazing conference, do you want to give a round of applause to the organizers? Awesome. Thank you. Now everyone else is going to be truly confused. But I finished very early. We're going to be spending the next hour talking about what's new in .NET 9 and C# 13. There's quite a lot happening with both the runtime, the platform itself, the SDK, the language, the tooling. So there's a lot that we're going to be discovering here today. It's going to be a little bit of a roller coaster. Before that, my name is Filip Ekberg. I've been here a couple of times before, and I do always like to tell people to send me emails, ping me on Twitter, let me know if you have any questions. I'm always happy to talk about what's happening with C# and .NET in general. So with that out of the way, we're going to talk about .NET. Right now, the latest stable version, or the latest supported version, is .NET 8. .NET 9 will be released in November, which is just in a couple of weeks. Every year, Microsoft releases one iteration of .NET. Every second year, that's a long-time support version. What they try to do now is focus on stability and performance and not maybe introducing so many groundbreaking features. There are a couple of features that are really interesting in .NET 9, and we're going to be trying to look at a couple of those here today. So let's start off talking about exactly what's happening with .NET 9. They're kind of focusing on developer productivity and performance. Performance has been a really important aspect of building .NET over the past decade, I would say, especially since .NET 5, 6, 7, and 8 and 9. So what's actually the contents of a .NET release? There's quite a lot of things. When you talk about .NET, it's not just like it used to be the framework. There's a lot of things around .NET that's important with a release of .NET. So with .NET 9, they focus on the stability portions. That goes for both mobile development, using Blazor, doing things in the runtime, making things faster in general and more stable. And that also brings us into the performance pieces. They do a lot of work making things a lot faster, be it how the compiler compiles the application, optimizing the instructions that use, but also introducing performance APIs and performance tools in the framework and the runtime. And we're going to look at a couple of those improvements here today as well. There's also a focus on productivity, and that's not only in terms of using Visual Studio and Visual Studio Code, but also in terms of making it easier to use certain APIs in .NET. Making it easier to write more flexible and scalable code, and doing so in a quite easy manner. And also letting us know if we're doing something incorrectly. And of course, they're also focusing on security, be that improvements of the cryptographic APIs, or making sure that we are using the best practices when it comes to, for example, OpenID Connect, which has a really groundbreaking change in .NET 9. There's also, of course, focus on web and tooling and mobile and a lot more, such as the languages. So when we talk about a release of .NET, it's going to be all of these different things, which is quite a lot to cover in an hour. So I've picked my favorite pieces of .NET together with the language. But it all really boils down to one thing, and that's really building anything. We can build any application for any platform, and they also want us to be able to build it from any platform. So if we're working on Linux or Mac OS or Windows, it doesn't really matter. As long as we publish this to Azure and pay Microsoft money, they're all happy. That's the end goal, though, right? .NET is free, C# is free, but eventually they want to get money from somewhere, which is why they make the experience using Azure quite great as well. Now, if we want to use .NET and C# and use the latest version of .NET, then we also get the latest version of the language together with that. So when we're using the latest version of .NET and the latest version of Visual Studio or VS Code and its tooling, you will also get the language features from that as well. While you can use newer versions of C# with older versions of .NET, that's not really supported and not something really you should experiment with. All right, so let's talk about some of the important pieces of .NET 9. We have all these performance improvements. Over the years, that's been working with spans of T and allowing us to use ranges and slice off data and do that very efficiently. They continue to do that by enabling us to use the spans with more APIs, and the runtime will make use of that, and the built-in stuff in .NET will make use of that as well. But performance is also about fine-tuning things internally. So bear with me here. When we're using the 64-bit compiler, and that sees a for loop. It will take the integer, like for I is equal to 0, that will be a 4-byte on the stack. But when you're accessing an array inside that for loop, that will have to be converted into an 8-bit number, or an 8-byte number. So what they've done is to introduce something called induction variable widening. This is very low-level stuff. But basically, that means they reduce one instruction for the CPU to use with each for loop, or with each iteration. And I guess all of us here are actually using for loops. So by introducing this performance improvement, they can speed up our applications marginally for all of us without us having to do anything. That type of work, together with allowing us to use spans-ft, is something that makes our applications a lot more performant. And the idea here is that we can just upgrade to the latest version of .NET, and we're going to get all of this by default, by just recompiling the application. We're going to be looking at some of the System.Text.Json changes. They've introduced feature switches. We're going to talk about some improvements to time spans. There's debugging improvements that I want to show you as well. They've also deprecated the binary formatter. Is anyone in here using the binary formatter? I'm sorry. With .NET 9, it's actually 2 out of, 150 people are using the binary formatter. There's a strategy for how you can transition from that, but it's now fully deprecated and no longer available in .NET 9. So you have to find a way forward, basically. And there's a lot more, of course. There's a lot more in .NET. They've done some work with LINQ by adding group by and aggregate by, for example. But we won't have time to look at all of that. I only have an hour. And I'd like to go through as much as possible in Visual Studio and show you a lot of interesting demos. So as you'll see here, I have a couple of demos for the base .NET stuff. This is basically what's available in all different applications using .NET 9. No matter if it's ASP.NET Core, Blazor, .NET MAUI, a Windows application, and so forth. Some of these are a little bit smaller than the others, but hopefully you'll all find a little bit of a nugget that you can apply in your applications. The first one is using what's known as a base64 URL encoding. How many of you are using base64 URL encoding? Almost all of you. Now, traditionally, when we have our byte array here and we want to base64 URL, base64 encode this, we then also have to apply some string replace or run this through a URL encoder. But now we have an API available for us built into .NET that allows us to do this. So of course, if I run this, you'll see here that the data that I get here, let's zoom in here. At the end here, we have a slash, which is not something that works when it's supposed to be in a URL, and therefore we have to replace the slash with an underscore, and that would require an extra operation, an extra method call, and more allocations. Having this built into .NET and doing this as performant as possible means that we can reduce allocations, we can have more performant code as well. Small addition, but it's nice to have that as a part of the .NET. I'm not going to call it a framework, but it is a collection of things, right? Now, next up, which is a little bit more interesting, they've introduced a concept called collection lookups with spans. So I said this is going to be a roller coaster of different things. We're going to look at a lot of different features of both .NET, .NET Aspire, the SDK. We're going to look at the language features as well. But here, you know, I can implicitly convert a string into a read-only span of character. So here I can say I have the string Filip. This can always be implicitly converted into a read-only span of a character. A span is simply a way for you to represent a piece of memory, be it like pointers, right? So it points to a start and an end of something. In this case here, it's a content of characters. And I have a dictionary of a string and a string here. Since a read-only span of a character could be implicitly converted into a string, would I be able to then say, I'd like to use my cache and use the key, which is a read-only span of character, but I cannot do that. So the only way to solve this in .NET 8 would have been to introduce an extra allocation, which is not essentially a good idea, right? Because now I'm doing an extra method call. I have extra allocations on my stack and on my heap as well, which is not very good. So they've introduced a concept called an alternative lookup. So I can now say that from my dictionary called a cache, I'm going to get an alternate lookup based off a read-only span of a character. So now this gives me a way to then work with my dictionary with this different type of lookup. basically what I can say is that, hey, in my lookup, I'm going to use this key here, which is really just allowing me to access elements inside my dictionary using a span instead. And the reason we want to be able to do this is because a lot of data now should be actually stored in spans or read-only spans, especially if you're working with .NET components that are optimized for performance. This here is all possible because there's a new feature in C#13 that is called allow ref structs. So what I can do is that I can use my lookup, which will then look up something in the dictionary based off my read-only span of a character. I find this pretty interesting as well. So more APIs internally will allow us to then leverage these highly performant types. All right, so next up is I would say an important feature as well, a little bit of a smaller one. How many of you are using feature switches? Not nearly enough. Okay, so about 10%. Feature switches is a way for me to toggle things on and off. We can do this in different ways. I can have a feature switch that enables something when the application is running based off a key in Azure, for example. I could also have a feature switch that disables code when I compile my application. Imagine I have my CD and CI pipeline that compiles one application version for development and one for production. The development version might have some experimental features, but the release version of that build shouldn't have those experimental features turned on. Now, in .NET 9, this is something that's built in by default. So I'm going to show you a little bit of a sample here. I have this class called a user service. The user service should have a flag telling me that if a feature is enabled or not. This is dictated by introducing an attribute called feature switch definition. And to make it easy, I've just named it the class name as well as the property name. And then where the magic happens is that I'm saying here that from this, I'm going to get rid of my regions here, just to make it easier for you all to read. And now, I'm saying that, well, based on my application context, I'm going to try and get a feature switch called the same thing. If it's enabled, I'm going to return true. If it's disabled, I'm going to return false. So this looks very simple. It basically just looks up a specific key inside the CS prod file. This is where this feature becomes a little bit difficult to work with, because you have to introduce an item group with a runtime host configuration option with the exact name, and then, of course, the value if this feature toggle is turned on or not. But where it's extra interesting is with this second parameter called trim, which is now saying that when I publish this, it's going to trim the application. And what that actually means is that all the code that relies on this feature switch, for example, if isEnabled is false here, it will remove that from the compiled binary. So that will actually not be included at all, unless I recompile the application, which is why we have this in the CS prod file, so that MS Build can look at this. So feature switches are an interesting addition as well. There's also a lot of improvements to System.Text.Json. So how many of you are using Newtonsoft.json still? How many are using System.Text.Json? The other half. Interesting. Should we have an open fight about which one is the best? Let's do it. So System.Text.Json was never meant to be a fully replacement for Newtonsoft.json, because Newtonsoft.json allows you to deserialize and serialize stuff that's complex, and it can do so with malformed JSON. It can just understand anything. System.Text.Json is built for performance. It's made because they want a performant alternative. And now they're, of course, introducing things that everyone wants as well, which might make it a little bit less performant, but they have to make a trade-off somewhere. So there's one option called indentation options, and here's where we're going to have the second fight of this talk. I can now say that which character I want to indent my code with. Should we use tabs or spaces? Tabs? Ooh, spaces. So the rest of you that didn't raise your hands for either of them, what do you want, like an at? Actually, this is not going to work. Should have raised your hand. So this is actually going to look at if it's tab or a space. So they're kind of forcing us into using one or the other. But this is nice. So now I can specify exactly how I want this indented when I output this. And I have to also then say that I want to write this as indented as well, so that when I output this, it's actually readable. Now, the next improvement is to allow us to use a a predefined class here, a singleton, to say that I want this to be using the ASP.NET Core defaults. So there's now a singleton saying, I want to use the JSON serializer options that are built for the web, and this will be identical to what you would then get for ASP.NET Core. It will be camel-cased and no spaces, and no tabs, no white space at all, basically. Now, how many of you have heard of OpenAPI? Oh, almost all of you, amazing. So we can now actually use a schema exporter. So OpenAPI is a specification to allow us to represent our APIs and our objects to get a representation of what it requires you to specify when creating that, the data types, and essentially it's just a JSON representation of your data and your endpoints in ASP.NET Core. But here I can say that I have a JSON schema exporter, and I can say that I'd like to get a representation of a class user. And it's going to use my default JSON serializer options. I could, of course, change this to web to make it then representable and use the ASP.NET Core defaults. So when I run this, I'm going to run this method called export schema. This will actually output exactly what my object is containing. So we can see here that it's an object. It has a couple of different properties, and 2 of them are, in fact, required as well. So it will maintain those annotations as well, which is tremendously useful, and something that's needed when we then deserialize our object. So we need to know exactly what's required and not. And the schema exporter is something that the OpenAPI addition to ASP.NET Core, which I'm going to show you later, is relying on. And we could have this as a part of the build process so that it generates the schema when we build the application and not actually expose a full endpoint in ASP.NET Core. But we'll get to that later on. We can also introduce something called respect nullable annotations. So when I've set up my JSON serializer options, I can say that I'd like you to respect the nullable annotation. The nullable annotation is this here, the question mark, or if it's a nullable reference type or not. And it should respect that, this should really be the default. So now, if I try to deserialize an object where I've said that, well, first name can be null in this case here, which would be valid JSON, but if the deserializer says that it has to respect the nullable annotations, and by default, string first name shouldn't be null, right? So if I run this, it's going to give me an exception. Here we go. First name on type user does not allow null values. This actually brings me to another thing that I forgot to mention about performance. How many of you are using exceptions as control flow? Ouch. That's 4 more people than I hoped for. Exceptions are extremely expensive because it needs to gather a lot of information about the call stack and a lot of information about what happened when your application runs. So using this for control flow can lead to a less performant application. With .NET 9, they've introduced faster exceptions, which is a new way of looking at how it captures the information when there is an exception. It's still a lot slower than the alternative, which would be to validate data using normal if and else's, rather than relying on exceptions. But there is a slight improvement in performance. So now when I have this, back to the nullable annotations, if I were to set this to a value, or actually change this back to false, I would then be able to deserialize this object without any issues. But honestly, I'd like to respect the nullable annotations and do true here, which I believe is the default inside ASP.NET Core. So if you're passing a model into an action and it's non-nullable, then it will throw an exception if it can't deserialize that, because it's actually a bad request. Now, next up, we can respect nullable for generics as well. So how would that work? If I have this type here, I'm going to have the exact same code. I'm going to say that I'm going to respect the nullable annotations. I'm going to set some property to null on my generic object. Let's actually look at what this looks like. I have a generic record here that simply now wraps a string. So really, this is the same as saying string data here, right? Actually, it's not. It's a lot more complex than that. But basically, that's what it's going to end up being. The problem is that when I run this method, it's the exact same code. I'm saying that it should respect the nullable annotations. The data here should not be able to be null because it's non-nullable. I'm going to run this, and it allows me to deserialize this with a null value, even though that I'm saying that it should respect the nullable annotation. The problem with generic parameters is that this here can be a struct, it can be a value type, so it won't actually apply that check for this, unless I apply this condition here to say that this will always be a reference type. And now when I work with the generics and this respect nullable annotations, this would be a little bit different. So this is a little bit of a gotcha that you may run into if you enable this feature. All right. The final one, in terms of improvements to System.Text.Json, is to respect there's a lot of respect in System.Text.Json nowadays. There's going to be respect required constructor parameters. This here means that when we are deserializing an object, if there's required, the default constructor requires a couple of parameters, should it use the default values if one is not provided in the JSON inside the JSON data? As you see here, I'm going to try and deserialize an empty object. Traditionally, what happens is that it tries to deserialize this, and it will use the default values. So if I say that you don't respect anything, and I'm going to run this, and I ran the incorrect code, let's do this. Let's run this again. Why is this not working? Let's try that again. There we go. Name is empty, so something didn't really work as it should have. It's actually, the thing is that I'm saying here, I'm not really going to respect that we have required constructor parameters, which means that it's going to use the default value of a string. If I say that it should always respect the constructor parameters, and I rerun that, it's going to tell me that I'm missing both the first name and the last name, so it cannot instantiate this object. So all of these additions to System.Text.Json just makes it easier and better to work with JSON documents. It makes it a little bit more complete, and I imagine that they're going to add a lot more features in the coming versions as well. So speaking of adding things that lets us write more performant code, there's now span support for more different types of APIs. So having spans available in .NET means that we can write more performant code, as it doesn't have to produce extra allocations. But there's a lot of built-in stuff in .NET that still haven't been able to use spans properly. So let's take a look at the additions here. One of them is the file helpers. For example, when we call file.writeAllText, previously, this only supported passing an array of let's see here. It only supports string content. So basically, what it had to do, if you passed a span, was to convert that into a new string, which meant extra allocations. Now, all of these different file helpers will allow you to use a read-only span of a character instead, just reducing the amount of allocations. And what's good about having these overloads is that it will try to use the better overload when it can. So if you're just upgrading to .NET 9, if you have similar code to this here, it will try to implicitly look at your code or implicitly convert that into a read-only span of a character. Next one is that there's a couple of extension methods to the span of t. Pretty much there's an extension method called starts with and ends with. So if we take a look at this text that I have up here, again, let me get rid of the regions. That's just to make it easier initially. I have my text. And I'm going to say that, well, if this here starts with hello, and I'm going to use an ordinal ignore case, so I don't really care about the casing, then I'm going to get a true or false back, basically. And this here actually will implicitly convert that as well into a read-only span of a character, and it will then match it to the start of that span. Doing this previously was a little bit tedious. But this isn't only in relation to using strings and characters. I can do the same for a byte array. So here I've used a collection expression from C#12 to set up a collection of bytes. And I'm using bytes here because it really makes me look like a hacker. Doesn't make a difference. So I have a read-only span of bytes here, which is essentially just a list of bytes. I have a pattern that I want to look for. I want to look for 0x12. And now I can say, well, if my data ends with that pattern, then this is going to be true or false. I could also pass an actual a collection of, let's do this. I could do that as well, and pass a collection of byte. And that would also work. So we can do more than one if we wanted to. So this is very flexible. And having these extension methods or these additions to what we can do with the spans is going to make our applications a little bit better. And this really boils down also to a new feature called params of collections added in C#13, where I can say that this here will in fact be converted when using string.join has added a params for spans of t and read-only span of a character, so that this will be implicitly converted into a read-only span of strings, or actually a params of read-only span of a string. So having that addition using params with collections means that we can have a more performant string.join as well, without having extra allocations. Seems like a small addition, but it can be important in some cases. Where I find myself, something that I've actually missed, is being able to split content. So I have a pretty recent course on Pluralsight where I talk about performance in C#, where I had exactly this sample, where I have an input which is a comma-separated content. I'd like to split that and do so effectively. Now, I can implicitly look at my string as a read-only span of character, as I've mentioned now a couple of times. This doesn't produce any extra allocations, doesn't have to copy any data over. It just lets me represent this content in a little bit of a different manner. Now, what I'd like to do is to say that I'd like to take my input and I'd like to split this on a comma, right? Normally, what happens when you do .split on a string is that it's going to allocate a lot of extra data. It's going to allocate a new array with all those different split portions. What this will do is that it will look for the first object, because this here is going to give me an enumerator. All right, so I'm going to get an enumerator that lets me get the different ranges. So basically, something that points to my first name here up until that comma, something that points to the second one, and third one, and fourth. So I can use a for each loop to say that, well, for each range of commas that I'm going to find here, or separated elements, I can iterate through this, and I can use my original content, or the original read-only span of a character, to slice off that range. So basically, now I can slice off Philip, Sophie, Mila, and Elise here without having to do any extra allocations whatsoever. This is a very memory-efficient way of doing a split on a string. The only extra allocation that I have here is when I convert that back to a string to just print it to the console. But this is a very nice way of scanning a document or parsing things and do so in a pretty memory-efficient manner. So this addition is actually something that I'm going to use quite a lot myself. Finally, there's an update to timespan. Timespan.fromSeconds, which has been available for a very long time. I don't know if you can see that in the back, but by default, it takes a double. Doubles are inherently bad with precisions because this number, if I run this, that number is actually not the same. I guess it depends on who you ask. But 822999999 is not the same as 823, right? Unless we get these rounding errors. So that's why they introduced an overload. And the funny thing is, like, this is the only number I found where it's a problem. So I'm very curious, who reported this bug? But it's in the release notes, so I'd like to just talk a little bit about this as well. Because I find it interesting that they add a bug fix for something that could potentially be a problem, but it's probably very rare. But now we have an overload from seconds that takes both the second portion and the millisecond, so that we don't get this rounding problem. We should really all just avoid using doubles. All right, so there's a lot of new stuff in .NET, and we've seen a lot of the things that are essentially added to the core library portions that's going to be applicable in all different types of applications, be it ASP.NET Core, .NET MAUI, Blazor, WinForms, and whatnot. So some of my favorite additions was actually the span improvements and being able to more effectively work with System.Text.Json. Now, next up, I'd like to talk about a couple of things in ASP.NET Core. Of course, that's also a big part of the .NET release, adding things to ASP.NET Core that are missing, or making sure that we can use APIs more effectively or more securely. So there's open API improvements, In fact, it's replacing the swashbuckle.asp.NET Core package, because that's now gone from ASP.NET Core. They used to bundle that together with the project template, but it's now gone because the project is no longer maintained. For some reason, it's better to build your own thing rather than jumping on an open source project and contributing to it. But yeah, that's what happened. So now they have their open API improvements added to ASP.NET Core, which is a good addition, I guess. They've done some SignalR trimming and native AOT improvements as well, which could be interesting if you're using SignalR. How many of you are using SignalR? Oh, that's awesome, about half. That's awesome. So if you're doing native AOT as well, this is going to be a nice update. There's something called a typed result, which has now had the introduction of the internal server error. I don't know why you would ever want to face internal server error externally, so I kind of like the idea of this not being a part of the typed results in ASP.NET Core, but now it's been added, because a lot of people kept adding it themselves. There's improvements to authentication and authorization. There's a thing called a hybrid cache. You can now use keyed DI in middlewares. And of course, there's a lot more. The first thing that I'd like to talk about, I'm going to pick a couple of things and show you in Visual Studio soon as well. But the first thing I want to talk about is the improvements to authentication and authorization. How many of you have heard of PAR, or Pushed Authorization Request? Ooh, amazing. One person. All right. So let's, for the next hour, talk about OpenID Connect. So PAR is a pushed authorization request. Basically, and I can now see here that this is a little bit difficult to read, but pushed authorization request is going to be the default behavior for OpenID Connect authorization and authentication in .NET 9. Traditionally, maybe this is easier to read, when you try to access a private page that is going to tell the browser to redirect to the IDP, or the authorization server, and it's going to send everything inside the get URL. The problem with this is that I could try and spoof it. I could try to change the scopes that I have access to. I could misuse this data here. I could change the redirect URI, hoping that someone would not validate this, and I could then create some really malicious requests. This is a little bit problematic. So instead, what's going to be happening is that there's going to be an extra addition to the website has to first talk with the authorization server. So we're adding a request here, a post request, which is going to validate your client ID, the secret. It's going to validate the return URL. And then it's going to send back something that doesn't have any details to it back to the client. This means that the website will have to do an extra call to the authorization server, which means a little bit of extra load on the authorization server. One extra call, that is. But it's for security, so it's good. It's a quite new addition to the specification, but it's something that will greatly improve the security, or at least that's the idea. It prevents scope modifications and really spoofing the clients and otherwise tampering or misusing with any of this data. So this will be enabled if you're using the Use OpenID Connect middleware. This will going to be the default in .NET 9 onwards, as long as the authorization server tells you that it allows pushed authorization requests, which it actually should. So let's take a look at some of the other things added in ASP.NET Core. I realized I could be talking all day about all of these different things, but we don't have time. First thing I want to show you is one addition. Now, you might have seen map static files, map static or map, whatever. The old thing that allowed you to map the static files is now going to be replaced with map static assets. And what this will do is allow you to compress the assets as it's building the application and reduce the sizes of your JavaScript, CSS, and HTML, so that when it delivers this to the browser, it will have a proper e-tag. It will know exactly if things have been updated or not. And effectively, you should be able to just say that you're going to use map static assets instead of the old static files. So tiny addition, making the requests and responses a little bit smaller. Next up, there's a little bit of a problem here. How many of you are seeing a problem with this? If you just ignore the squiggly, there's just one person seeing a problem with this. That was really quickly as well, if it's the same problem, that is. So the issue here is that I'm saying that I have a controller where I want to allow anonymous access, but I have one endpoint inside this controller where I require the user to be authorized. Does this work? It's a rhetorical question. No, it doesn't. Because this will actually be overridden. And I realize that the text here in Visual Studio is a little bit tricky to read, but it's basically saying that authorize here is going to be overridden by allow anonymous. So you won't be able to do this. And previously, you didn't get any hints whatsoever until you ran the application and realized it doesn't work. This will also look at base classes, and if this is inheriting from a base controller, that would work as well. So that's a nice addition, being able to scan the library to find these problems and let you know about them as well. And if we treat warnings as errors, this would become a compiler error, which is great. Now, there's a couple of more minimal API improvements. There's the addition of OpenAPI, so we can say that I'm going to add OpenAPI and then map OpenAPI to my application. And when I do so, this will expose an OpenAPI endpoint, and I could then get a very nice representation of my, let's see if I can zoom in. That's a little bit too much. There we go. This will now give me a representation of my entire API, basically. It will have all the types. It will know about all the different response codes that your endpoints can return. And it will know that because, in this case, if we look at the code that I have here, I have an endpoint that allows me to return two different results. So the root of my application can return either an OK of a string or an internal server error. And this here is one of those additions to ASP.NET Core as well. Let me just do this. Here we go. So the OpenAPI middleware will scan our application and will know exactly what's going to be returned from this as well. Now, I'd like to show you a couple of debugging improvements. So I have, first of all, I'm going to put a breakpoint in here. I'm going to run this with the debugger attached. And I'm going to navigate to /signin. And when I hover this here and go into the request, I'm going to zoom in. I just have to find this thing first. Hopefully, fail. Let's try that again. Request. Here we go. Come on. Oh, that's a nice addition, isn't it? So instead of having a really bad experience when debugging the application and looking at a dictionary, now it actually shows the dictionary key on the left-hand side and the value on the right-hand side here. Small addition, but it makes all the difference when we're debugging our applications. So again, the developer productivity portion of improving .NET and the developer experience. I'm going to release this debugger, and this here is going to create some fake data. And then I have a, I believe, data endpoint, or whatever that endpoint was called. Let's see here. I'm going to release the debugger, run this without debugging, go to /signin, create some data, and then go to the data endpoint. Hopefully, after a couple of seconds, this here should show me a developer exception page. And for some reason, it doesn't do that anymore. I was going to show you some of the really interesting... Oh, here we go. Of course, because I don't have any internet connection. I would have gotten an exception anyways. So they've improved this as well. There's now a little bit of more information in here. I can scroll down, and I could, if this was actually... I can see here at the bottom, I can even expand the code portions of where this is going to be a problem. And if I would have had internet connections, this here would actually have thrown a null reference exception, which is what I wanted to demonstrate, because it will now actually show you exactly where the null reference exception happened, even if it's an asynchronous operation, which was a little bit problematic before. And not only that, this developer exception page now has information about the query string, the available cookies, the headers, and the routing, and so forth. So you can use this to analyze exactly what's going to go on. All right. Small addition to ASP.NET Core. So there's, of course, a lot more happening in ASP.NET Core. But basically, the most important ones here are the improved debugging experience and the OpenAPI addition as well, together with one more interesting thing called a hybrid cache. a hybrid cache, which is added by simply adding a call to add hybrid cache after you've added a reference to that extension package, gives you the capability of simply replacing all in-memory caches. The hybrid cache is actually a two-way or it will cache in two places, or allow you to cache in two places. Primarily, it will cache in memory, but if you've also set up a distributed cache, like you normally do with, for example, add stack exchange Redis cache, which is implementing the iDistributed cache, if that's available, it will also use that secondary cache. So you can have an in-memory cache running on your system, and you can also have an off-site cache running in Redis in Azure, for example. So if you restart the web server, it will first try to fetch something from memory. There's no cache hit, so it will go ahead and ask the external cache provider. If there is a cache hit, it will then populate the in-memory cache and return the value. The reason this is a hybrid and two-store cache is because that will then allow you to be very performant, but also you can restart your web application and the cache is persistent. And of course, I can also, if I use this hybrid cache in one of my minimal APIs, I can say that I'd like to use the hybrid cache to get or create something. Here's my cache key. If there's a cache hit in memory, it's going to return that. If there's a cache hit in the distributed cache, it's going to return that as well. If there's no cache hit, I can tell it to retrieve that specific thing, and I've just added some sample data here. And then if I have somewhere in my application where I still rely on the iDistributed cache, that would also be able to retrieve this data as well. So this is a very nice addition. And so you should be able to simply replace all your in-memory caches using this instead. The approach of using this is slightly different from reading and writing to the in-memory cache as well. And this will also bake it into a specific type when it's serializing and deserializing the data. You can even override how it serializes if you'd like to use protobuf, for example, instead of JSON. So it's very flexible. All right, so being conscious of time, let's see here. We've talked about all of the things inside ASP.NET Core that I find are interesting, optimizing static files, the authorization attribute, and of course the hybrid cache. Let's now switch gears and talk a little bit about .NET Aspire. Is anyone using .NET Aspire for local development? Okay, about a handful. Hopefully, more of you will start using this because it's a great tool. It allows you to very easily set up, or I would say, set up a tool that orchestrates your different services. So let's say that you have a web application, you have a couple of APIs, you might have a Redis cache, and you want to spin all of that up locally and do so quite easily. .NET Aspire allows you to do this and define all of those different dependencies. It allows some service discovery so that if your web application is relying on an API or relying on a Redis cache, it can feed that application with information about how to find it. It also gives you structured logs. It gives you the capability of restarting and starting applications, doing a whole lot of things. Where people tend to be a little bit baffled is when you want to release the application. So while this is meant for local development, you still have to have a process of distributing the application. If you'd like to distribute this to Azure and use Azure Container Apps, there's a lot of good information about how to do that. But if you want to have a different structure, it's a little bit more difficult and a little bit more hands-on that you have to do. So with .NET Aspire 9, which was released as Release Candidate 1 yesterday, they introduced the support for persistent containers, also introduced custom commands, health checks, Azure Function supports, and an overall better experience. So I think let's jump over to Visual Studio and take a look at what .NET Aspire is actually all about. So when you create a new sample application with .NET Aspire, basically you get your API as a sample. I have an API service. This is just an ASP.NET Core application. I then have my Blazor application, which is my web front end. I don't know why you want to open that up, but I have my Blazor application, and my Blazor application references the API. It also references a Redis cache, for example. And setting up that dependency is done in an app host project. This is .NET Aspire. So I'm going to go in here, and I'm going to show you that, just ignore the warnings. I promise this works. So, for example, I'm creating a Redis cache. And what this will actually do is that this will pull down a Docker image and start that for me. And since I've said that the container lifetime is persistent, this will be running outside of my application as well. If there's no Docker container running, it will pull it down from docker.io or whatever register you're using, and it will start that, and when you kill your application, that container will still be running in the background. The reason you want to have this support is because it increases or decreases the startup time. Then I'm saying that, well, my application also have an API services project that references my cache. I also have a web frontend where I've introduced a custom command called dump database. Sounds very, very interesting. This also has external HTTP endpoints. It has a reference to my API service. And before starting this application, it should wait for the API service to start. So before I actually go into the web UI, let me just show you exactly what that command is. So I've set up an extension here where I simply have a dump database command, which takes a project and then has a text for a button in the UI called delete database. And then I can run some code in here to delete the database and return true or false based on if that worked or not. So keep that in mind when I know, go ahead and start the project. I'm going to jump over to Mac OS because I'm running in Parallels, and Parallels doesn't have support for nested virtualization. And if this doesn't work the first time, just run it again and it should work. But this time it worked the first time. Come on. There we go. And now we can see here that this here has a little persistent icon on it. Means that this here is in fact a Docker image from docker.io. And I can see that by going and doing docker.ps and see that this is actually a Docker container that I created 23 hours ago, and it's been up for 14 hours. If I restart the start the application again and refresh, come on, here we go. Now I can see my applications. I have my API service, I have my web frontend, I have my, let's see here, I have my delete database command here at the bottom. I could run that, and that will then run that command as well. So this here is meant to speed up the development process of local development. It allows you to point to the different projects that you rely on, be it a Docker container, be it your own ASP.NET Core projects or web frontends, and it can feed information between the different ones. All right? So I find this very interesting, and I could use the same Redis container for my distributed cache in the other application if I wanted to as well. All right, so, and also, here's one more change. When you click one of these things, it opens up the panel on the right-hand side. They're very proud of that. Because previously it opened at the bottom. I don't know what they were thinking. Kidding. If that would have been the biggest addition to .NET Aspire, I would probably not have included it. All right, so there's a lot of things happening with .NET Aspire. And if you haven't checked it out, try and add it to a new project and see if it helps you build your applications locally. And with the support of Azure Functions and built-in health checks and stuff like showing you the telemetry logs and all of that, this is a good tool. How many are using Blazor? Okay, about half. There's a lot of additions to Blazor as well. There's, for example, there's now a new template when you're creating a new project, if you want to do that, that lets you do a hybrid application between Blazor web as well as mobile. There's additions to .NET MAUI. Who's using .NET MAUI? Okay, about a handful. That's great. There's also a lot of additions to .NET MAUI. Being conscious of time, I'm not going to spend too much time talking about Blazor and MAUI. But they're both powered by all of the greatness added to .NET 9 in terms of performance and all the language features as well. And in .NET MAUI, there's a lot of bug fixes. I've personally been looking forward to this release because there's a lot of fixes as well as Xcode 16 support. So I'd like to spend the last 10 minutes talking about C#13. And the reason we don't spend more time talking about C#13 is because there's already so many great language features added to C#. This feature, or this release of the language, includes a couple of interesting features, but mainly they're focusing on performance, just like they're doing in .NET. They're also focusing on stability and ensuring that they're relying on those old language features that they introduced to make them a little bit better. So C#13, while it does introduce a couple of things, it's not as major as C#12. So it introduces a new thing, a new keyword, a field keyword. It introduces params collections. It introduces a new lock object, which was something added to the .NET runtime as well as .NET, to allow us to use a new semantics internally, and also allow us to more effectively lock on object if you're working in multi-threaded applications. There's implicit index access, overload resolution priority, and potentially, there's also partials, and potentially a couple of more things. It's still a couple of weeks out until they release the final versions of .NET 9 as well as C# 13. So bear in mind that they could scratch a couple of the language features or make some additions to what's already been added to .NET. But I would be very surprised if they did any major changes a couple of weeks before they actually release and go live. It's just me that do things the night before I go live with a new product. Probably not. So the field keyword is going to be an interesting addition. So notice here that there's, inside my auto property, I can now reference a field. So who in here thinks I'm actually referencing this thing? Who in here thinks I'm referencing this? Oh, great, you got the idea of this being a rhetorical question. It's actually not going to reference that field at all. This here is now a new contextual keyword that allows you to reference the backing field of the auto property. And the reason you can do that is so that you can then access it and, for example, trim the value before you set the field to a value, or modify it before you return it to whoever calls that auto property. But then, if you already have code that looks like this in C# 12, because this is valid, right? This will then reference that previous field. Then what happens? I think this is the first time they introduce a breaking change in the compiler, because that will actually break your code. So doing this, if you already have a variable called field, this here is a breaking change, because you have to use keyword escaping. The @ here, the @ symbol, we have to use this to escape the keyword, just like we do for any other keywords or contextual keywords, to escape that and remove what it actually means, right? So I think this is a nice addition as well, because it now allows you to modify the values or work with it before you return it back to whoever's consuming this. There's also this addition of a params collection. So notice here, I have a lot of different overloads for this process method. I can say that I have a params of a string array, I have a params of IEnumerable, a span, a read-only span, immutable list, and list. We can use the params with anything. And this builds on the collection expressions. It works with spans, it works with read-only spans, it works with all IEnumerables. It tries to avoid implicit conversions. And this here, if we have both span of string as well as the array of a string, it will favor the span of a string, because that's more performant, right? Reduce allocations and copying information over. And when it can, it will pass this as a value parameter for implicit conversions. So then, here, we can pass it as both as a collection, as you see here. There's two different call to process. The first one passes it as params. The second one passes it as a collection. And both of these different ones work. But how will it know which one is most suitable? Because these two are, in fact, going to be ambiguous. There's a new thing called overload resolution priority. If it cannot determine which one of these two is more suitable, we can tell the compiler which one we'd like to have priority. Right? So I can say that read-only span of a string should have higher priority if there's an ambiguity. And that would both reduce or remove the compiler error. It will also favor the one that's more performant. Okay, so I think that's a nice addition as well. Next up is this new lock object. This here is a new type available in .NET. And this provides better thread synchronization through a new API. It was added in the .NET runtime and also added in .NET, the SDK, as a type available. And now it's using this API instead of that old monitor-based API or monitor-based locking. The idea is that it's going to be a little bit more suitable and a little bit performant, I guess. So that's a nice addition as well. And then we also have this introduction of partial properties. Now, this here, actually, let me show you this in Visual Studio instead. Partial properties. We had partial types for a very long time. But they've kind of been missing from properties, right? So I have this partial class where I have a partial property called name and a partial method called process. Why on earth would you do this? Well, it's because of source generators. So I could say that this here is a partial property that I want you to generate some source code for. And that source generator can look at which target platform you're currently building for and generate the appropriate method. For example, regexes, right? But of course, if we want to implement this user, we simply just create a new partial class in the same project. And this would have worked with a source generator as well. That's exactly what it's doing behind the scenes. And actually, finally, let's take a look at the, while I'm in Visual Studio, I might as well show you the implicit index access as well. So here, I have a data type called data, which exposes a public byte array, which I initialize to 5 available spots. And let's say that I'd like to initialize this with some predefined values. And of course, being a hacker, I'm still using my bytes here. So I can now say that from the first, or from one off the end, which is in fact the last element. The last element should be 0x5, the second to last, third to last, fourth, fifth to last, which is in fact the first element. And if I run this, it should then say 1, 2, 3, 4, 5. Right? So this implicit index access allows us to then reference different values depending on where in that array you want to set those values. And we don't have to specify all of them. Let's see actually what happens if I do this. That would then also work, of course. So I can use this to set particular values based off the end of that collection. All right. So then I guess, what's next? What's coming next in .NET? What's happening with C# as a programming language? Having a couple of minutes left, let's talk about the entire roadmap. Probably not going to happen. There's a lot happening with C# and .NET in general. We've kind of scratched the surface of some of the more important features being added to .NET. The most important parts are probably performance, and how the language uses these different features when it's compiling your application, making use of smarter optimizations when it's compiling for 64-bit processes, making sure that it uses native AOT when possible, and then trimming away information that it doesn't need. Internally, .NET will heavily use the new feature switches to allow it to then remove and reduce the final binary when you're producing one of those native ahead-of-time compiled code pieces. And in terms of the language, there's still a lot that they would probably want to add, like discriminated unions, for example. That's something that they've talked about for a very long time. And another quite important one is extensions everything. They talked about a concept of extensions everything ever since I think they started with a Roslyn compiler. The Roslyn compiler is what's powering this new C# and VB compiler. It's the new compilers, basically, which is now called the Microsoft Compiler Platform. Ever since they started this work, they talked about extensions everything, which is basically the same idea of allowing you to have an extension method, but you could add to any type and add anything. You could add properties and methods and so forth to anything available in your application. But this didn't make it into C# 13. They talked about this right up until, I think, build this year, but then a couple of months ago, they announced that they withdrew this from the language. And they tend to do that for things that they don't feel is essentially completed. So hopefully, extensions everything gets into the next version of C# as well. So with that being said, there's a lot happening in .NET and in C#, and I hope this has given some inspiration as to what you can look at. And if you like to listen more to what I have to say, I have a bunch of courses on Pluralsight covering things from security to performance in C# and all the advanced language features you could think of in a little bit more of a slow-paced manner. So hopefully, again, you like this. If you have any questions, I'm always available to have a chat. Ping me on Twitter, send me an email, experiment with the new stuff in .NET. I got a ping like last night about a new version of Visual Studio. Who thinks I updated? Exactly, I didn't, because that would have been interesting today. It would break all my demos. But they just released a new preview version, and it's all Go Live license as well. So if you want to experiment with .NET 9, it's a Go Live license, you can do that, and it's all supported. So thank you so much for coming. If you would like to, leave a green tick on the box. If you didn't like this talk, you can skip the line and go and get a coffee. All right? Thank you.